Welcome to our comprehensive guide on the top 50 senior Android developer interview questions and answers. Whether you're preparing for your next big interview or simply want to sharpen your skills, this video will walk you through the most critical topics, from Kotlin coroutines to Jetpack Compose, architecture, performance, testing, system design, security, and CI/CD. We'll break down each section, highlight key concepts, and provide practical insights to help you stand out. Let's dive in and start with the fundamentals that every senior Android developer should master. Kotlin coroutines are essential for modern Android development. Understanding the difference between launch and async is crucial. Launch returns a job and is used for fire-and-forget tasks, while async returns a deferred and is used when you need a result via await. Structured concurrency is managed with coroutine scope, which keeps coroutines tied to a lifecycle. When the scope is canceled, all coroutines inside it are also canceled, ensuring safe and predictable concurrency. These basics lay the foundation for robust asynchronous programming in Android. In Android, understanding flow, stateflow, and shared flow is vital for managing data streams. Flow is a cold stream, recomputing for every collector. Stateflow is hot, retains the last value, and is ideal for UI state management. Shared flow is also hot, emits to multiple collectors, and offers configurable replay. These tools help developers efficiently handle data updates in UI state, making apps responsive and robust. Mastering these concepts will help you build scalable and maintainable Android applications. Handling exceptions in coroutines is a critical skill for any Android developer. You can use try-catch blocks for simple cases, coroutine exception handler for global handling, or supervisor scope to isolate failures. Choosing the right approach depends on the context and the desired behavior. Proper exception management ensures your app remains stable and prevents crashes, especially when dealing with asynchronous operations. This knowledge is key for building resilient Android applications. Understanding the difference between with context and run blocking is essential. With context switches context within a coroutine, allowing for efficient thread management. Run blocking, on the other hand, blocks the current thread and is typically used in tests. Knowing when to use each ensures your code is both efficient and testable. This distinction is fundamental for writing clean and maintainable coroutine-based code in Android. Jetpack Compose revolutionizes UI development in Android. Recomposition is the process where Compose tracks state used in a composable. If the state changes, only the affected parts are recomposed, making UI updates efficient and responsive. This mechanism reduces unnecessary redraws and improves performance, allowing developers to build dynamic interfaces with ease. Understanding recomposition is key to mastering Compose. Jetpack Compose, Remember and Remember Savable are used to retain state. Remember survives recomposition only, while Remember Savable survives process death by leveraging save state handle or bundles. Choosing the right state management approach ensures your app maintains user data across configuration changes and process restarts. This distinction is crucial for delivering a seamless user experience. Managing state in Jetpack Compose can be achieved using ViewModel, Remember, Stateflow, or Remember Savable. Each method has its own advantages, depending on the complexity and lifecycle requirements of your app. ViewModel is ideal for sharing state across composables and surviving configuration changes, while Remember and Stateflow are suitable for local state. Effective state management leads to robust and maintainable UI. Using keys in Lazy Column helps Compose identify and efficiently update items, preventing UI glitches. Keys allow Compose to track individual items, ensuring smooth animations and updates. This practice is especially important when dealing with dynamic lists, as it avoids unnecessary recompositions and improves performance. Mastering keys is essential for building responsive list-based UIs. Custom modifiers in Jetpack Compose allow developers to extend UI behavior. By using modifier draw with content or modifier layout, you can create unique visual effects and layouts. Modifiers are powerful tools for customizing composables, enabling advanced UI designs and interactions. Understanding how to build and apply custom modifiers will set you apart as a Compose expert. Clean architecture separates your app into UI, domain, and data layers. Dependencies point inward, meaning UI depends on domain, and domain depends on data. This structure promotes maintainability, testability, and scalability. By following clean architecture, you ensure your codebase remains organized and easy to evolve, which is crucial for large projects and team collaboration. MVVM and MVI are popular architectural patterns in Android development. MVVM is simple and widely used, offering clear separation between UI and business logic. MVI, on the other hand, is unidirectional and predictable but can be verbose. Choosing the right pattern depends on your project needs and team preferences. Understanding both helps you design scalable and maintainable apps. Large Android projects benefit from modularization, dependency injection, and shared contracts or interfaces. Modularization divides your codebase into core, data, and feature modules, making it easier to manage and scale. Dependency injection tools like Dagger, Hilt, or Coin simplify dependency management. Shared contracts ensure consistency across modules. These practices are essential for successful team development. Decoupling business logic from UI is a best practice in Android development. Use ViewModel, repository, and use cases to separate concerns, making your code more testable and maintainable. This approach allows for easier updates and reduces the risk of bugs. By keeping logic independent from UI, you ensure your app remains robust and adaptable to changes. Dependency injection provides dependencies externally, improving testability and flexibility. Popular tools include Dagger, Hilt, and Coin. These frameworks automate dependency management, reduce boilerplate, and support modularization. Mastering dependency injection is essential for building scalable and maintainable Android applications. Work Manager is used for reliable background tasks, such as syncing data. It survives app restarts and respects constraints like network availability. Work Manager is ideal for tasks that must be guaranteed to run, even if the app is closed. Understanding its use cases helps you build robust background processing in Android. Paging 3 uses Paging Source, emits paging data, and works with Flow to manage load states. This library helps you efficiently load and display large data sets, reducing memory usage and improving performance. Understanding Paging 3 internals is key for building scalable list-based UIs in Android. The navigation component manages navigation with NavController, handling fragments and arguments. It simplifies backstack management, ensuring smooth transitions and state retention. Mastering the navigation component is essential for building user-friendly navigation flows in Android apps. ViewModel is tied to lifecycle owners and survives configuration changes via ViewModel Provider. This ensures your app retains state across rotations and other changes, providing a seamless user experience. Understanding ViewModel survival is crucial for robust state management in Android. Room enforces off-main thread database access, supporting suspend and rx/flow APIs. This ensures smooth UI performance and prevents ANRs. Understanding Room's multi-threading capabilities helps you build efficient and responsive data-driven apps. Launching an activity in Android involves creating an intent, which is processed by the OS. The activity lifecycle then proceeds through onCreate, onStart, and onResume. Understanding this flow is fundamental for managing UI and user interactions. Configuration changes destroy and recreate activities unless handled manually. Using ViewModel to retain state helps preserve user data across changes. Mastering lifecycle management is essential for delivering a consistent user experience. Preventing memory leaks is crucial for app stability. Avoid context leaks, clear listeners, use Leak Canary, and employ weak reference when needed. These practices help maintain optimal performance and prevent crashes. Looper reads messages from the queue, while Handler sends and receives messages tied to a looper. This mechanism is fundamental for managing threads and asynchronous tasks in Android. Understanding these components is key for efficient background processing. Android offers several service types: service for background work, foreground service for tasks requiring notifications, and intent service for sequential tasks, now deprecated. Understanding the differences helps you choose the right service for your app's needs. Profiling tools like Android Profiler, Systrace, Leak Canary, and GPU rendering analysis help identify performance bottlenecks. Using these tools ensures your app runs smoothly and efficiently, providing a better user experience. Reducing APK size is vital for faster downloads and better user retention. Techniques include R8 Pro Guard, resource shrinking, vector drawables, and modular delivery. Applying these strategies helps optimize your app for distribution. Finding memory leaks involves tools like Leak Canary, Heap Dumps, and Memory Profiler. Regularly checking for leaks ensures your app remains stable and efficient. This practice is essential for maintaining high-quality Android applications. Optimizing lists in Android involves using lazy column with keys or recycler view with diffutil. These techniques improve performance and ensure smooth scrolling, especially with large data sets. Mastering list optimization is key for responsive UIs. Lazy loading images with Glide, Coil, or Picasso, combined with caching and placeholder strategies, ensures efficient image handling. This approach reduces memory usage and improves user experience, especially in image-heavy apps. Unit testing view model involves using JUnit, mocking dependencies, testing state and output, and using Turbine for flow. Thorough testing ensures your business logic works as expected and prevents regressions. Testing coroutines in Flow uses Run Test, Test Dispatcher, and Turbine. These tools help simulate asynchronous operations and verify correct behavior, ensuring your code is reliable and robust. Robolttrick is JVM-based, allowing fast unit tests without a device. Instrumentation tests run on real or emulated devices, providing more accurate results. Understanding the differences helps you choose the right testing strategy. Mach-K and Mockito are popular mocking frameworks. They allow you to create mocks, define behavior with every or when, and verify calls. Using these tools ensures your tests are isolated and reliable. Espresso is a UI testing framework that simulates user actions and assertions on views. It helps ensure your app's UI behaves as expected, catching issues before release. Mastering Espresso is essential for delivering high-quality Android apps. Offline-first app design uses Room, Work Manager, View Model, and Repository to sync with the backend when network is available. This approach ensures your app works reliably even without connectivity, providing a seamless user experience. Dynamic feature modules allow modularization by feature, using Play Feature Delivery and Navigation component. This approach reduces APK size and enables on-demand loading, improving app flexibility and performance. Modularization divides your codebase into core, domain, data, UI, and feature modules. This structure improves maintainability, scalability, and team collaboration. Applying modularization is key for large Android projects. Remote and local sync strategies use the repository pattern, caching locally and syncing via Work Manager or background sync. This ensures data consistency and reliability, even in offline scenarios. Handling large data sets involves using Paging 3 with filters and sorting in the DB layer and view model. This approach ensures efficient data loading and smooth user experience, even with extensive datasets. Storing sensitive data securely uses encrypted shared preferences or Android Key Store. These tools protect user information and comply with security standards, ensuring your app is safe and trustworthy. ProGuard is used for code obfuscation, shrinking, and optimization. It helps protect your app from reverse engineering and reduces APK size. Using rules allows you to exclude important classes from obfuscation. Best practices for permissions include explaining rationale, checking before requesting, and handling denial cases. These steps ensure users understand why permissions are needed and improve trust in your app. Preventing reverse engineering uses ProGuard R8, native code, signature checks, and avoids exposing secrets in the APK. These measures protect your app from unauthorized access and maintain integrity. App integrity and signing involves signing with KeyStore, verifying on the backend, and using Play App Signing. These steps ensure your app is authentic and secure, preventing tampering and unauthorized distribution. CI/CD setup uses tools like GitHub Actions, Bitrise, and Jenkins to automate tests, builds, and publishing. This automation streamlines development, reduces errors, and speeds up release cycles. Gradle is the build system for Android, resolving dependencies, compiling code, and generating artifacts. Understanding Gradle's workflow is essential for efficient builds and project management. Build variants use product flavors and build types to create separate dev, staging, and prod builds. This flexibility allows for targeted testing and deployment, improving development workflow. Firebase Crashlytics monitors crashes, logs custom events, tracks versions, and sets up alerts. This tool helps you quickly identify and fix issues, ensuring your app remains stable and reliable. Maintaining code quality across teams uses static analysis tools like Lint and Detect, code reviews, CI checks, and shared conventions. These practices ensure consistency, prevent bugs, and foster collaboration. Further enhance your Android development skills. Explore recommended resources from Medium and other platforms. Articles on tricky interview questions, advanced view model patterns, and real-world lifecycle guides provide valuable insights. Continuous learning is key to staying ahead in the fast-evolving Android ecosystem. Reading about interview experiences, such as those at PayPal or other major companies, can provide practical tips and boost your confidence. These stories highlight common challenges and strategies for success, helping you prepare mentally and technically for your own interviews. The Android development landscape is constantly evolving. Staying updated with curated questions and answers, as well as following expert advice, ensures you remain competitive. Dedicate time to learning new patterns, libraries, and best practices to keep your skills sharp. In summary, mastering these 50 interview questions and answers will prepare you for senior Android developer roles. Focus on understanding core concepts, practical tools, and best practices. Stay curious, keep learning, and approach each interview with confidence. Good luck on your journey to becoming an expert Android developer.